Assalamualaikum warahmatullahi wabarakatuh. To saya Saiful. Today I would like to discuss about my lab regarding buckling of strut. So now I would like to present the apparatus. The first one is flexural test apparatus. I used cardboard to make this apparatus. Next is the beam specimen. We are assuming this ruler as a beam specimen. And the last one is ruler. Ruler is used to measure the dimension of the beam specimen. As the first step, we need to measure the dimension of the specimen. The first one, we need to measure the length of the span, and then the width of the specimen, and the thickness of the specimen by using ruler. Next, we need to turn on the load indicator. After switch on the indicator, we will put the beam specimen into the bottom platen, and we will tighten it by using Allen key. So after that, with the top platen, we can adjust it until it just touching the surface of the top specimen. As you can see here, I am adjusting the top platen, and then the needle of indicator need to touch the center of the beam specimen. If the load indicator showing that it is greater than 10 Newton, then we need to reduce it until it less than 10 Newton. As you can see that I am achieving until 8 Newton. Then the indicator should be turned into 0 by pressing tap button. The deflection indicator should be start from 0 by increasing the load gradually until it changing the deflection indicator. As you can see here, the indicator has changed. However, precaution must be taken not to apply the load exceed of the load critical that can cause damage to the beam specimen. Since this experiment is applying both end pin, so the load critical can be calculated by using the formula of critical load is equal to constant pi squared EI over L, where E is the Young modulus, I is the second moment of inertia, and L is the length of the span. So after that, we can get the critical load. The load that causing the changes in deflection must be recorded and tabulated. Repeat all the steps until at least 5 times. After done with the experiment, this is the expected data of the experiment. As you can see, we will record the load and mid-span deflection. Load can be obtained by reading at the load indicator, and mid-span deflection can be obtained by reading at the deflection indicator. So as you can see, the increasing of the load causing the increasing of the deflection. This negative sign indicating the direction of the deflection that happened. To calculate this D over P, we need the deflection divided by load. As you can see, the first one is 0.04 divided by 7.6, which is we can get 0.005 mm over Newton. And this is the other calculation, and after that, convert the answer into tabulated data. So that is all from expected data. As for analysis, graph deflection versus D over P will be plotted. As you can see, this is the graph. The relationship between deflection and D over P is linear to each other, where increasing of deflection will increase the D over P value. So I think that is all from me. Thank you to Sir Saiful again for helping me to finish this project. Assalamualaikum warahmatullahi wabarakatuh.